In the vast, dark expanse of the cosmos, a titanic dance is unfolding, a dance that could one day rewrite the fate of our very own Milky Way. Andromeda, our nearest large galactic neighbor, is hurtling towards us at a speed of about 110 kilometers per second. In a few billion years, the skies as we know them will be transformed as these two grand spirals collide and merge. But what will this cosmic encounter look like? How will it reshape our galaxy, our solar system, and perhaps even life as we know it? Join us as we explore the fascinating science behind this inevitable galactic rendezvous, blending cutting-edge astrophysics with tantalizing speculation about our cosmic future. This isn't just a story about what's happening out there. It's a story about what's happening to us, to our home, and to our destiny among the stars. The cosmic neighbor, Andromeda's proximity. In the vast, dark expanse of the cosmos, our Milky Way galaxy has a neighbor, a massive and majestic one at that. Andromeda, also known as M31, is a spiral galaxy much like our own, but with a staggering trillion stars to our mere 100 billion. It's the closest major galaxy to us, a mere 2.5 million light-years away. This proximity makes Andromeda a crucial subject of study for astronomers, offering a unique opportunity to understand the dynamics of galaxies and their evolution. Andromeda is not just close. It's approaching us at a breathtaking speed of about 110 kilometers per second. This is not a cause for alarm, but rather a cosmic dance of epic proportions. In about 4.5 billion years, Andromeda and the Milky Way are expected to collide and merge, creating a new, larger galaxy. This future event, often referred to as Milkomeda or Milkdromeda, is a fascinating subject of speculation and study. The exact nature of this collision is still a topic of debate, with some scientists suggesting a direct hit and others a more glancing encounter. Regardless, the outcome will be a spectacular display of cosmic fireworks, reshaping the night sky as we know it. The study of Andromeda's proximity has also led to significant advancements in our understanding of dark matter. By observing the rotation of stars within Andromeda, scientists have been able to map the distribution of dark matter in the galaxy. This elusive substance, which makes up about 85% of the matter in the universe, does not emit, absorb, or reflect light, making it incredibly difficult to detect. Andromeda's proximity allows for more detailed observations, providing valuable insights into the nature of dark matter and its role in the universe. Moreover, Andromeda's approach offers a unique opportunity to study the effects of galactic collisions on star formation and evolution. When galaxies collide, their gravitational interactions can trigger intense bursts of star formation. By observing Andromeda, scientists hope to gain a better understanding of these processes and the conditions that lead to the birth of new stars. This knowledge could shed light on the origins of our own solar system and the conditions that gave rise to life on Earth. The cosmic dance of Andromeda and the Milky Way is not just a spectacular display of celestial mechanics. It's a window into the past and future of our universe. A galaxy in motion, understanding galactic drift. In the vast expanse of the cosmos, galaxies are not static islands of stars, but dynamic entities in constant motion. Among these, the Andromeda Galaxy, our closest major galactic neighbor, is on a collision course with the Milky Way. This dance of the Titans is a slow-motion drama, unfolding over hundreds of millions of years. The Andromeda Galaxy is hurtling towards us at a speed of about 110 kilometers per second. This motion is not a straight-line charge, but a complex drift influenced by the gravitational tug-of-war with the Milky Way and other celestial bodies. The concept of galactic drift is crucial to understanding this cosmic ballet. It refers to the slow, gradual movement of galaxies relative to one another, driven by the intricate interplay of gravity, dark matter, and the expansion of the universe. The future of this galactic encounter is a subject of both scientific inquiry and speculative wonder. Current projections suggest that Andromeda and the Milky Way will collide in about 4.5 billion years. However, the exact nature of this collision remains uncertain. Will the two galaxies merge into a single, larger galaxy, or will they pass through each other, only to be drawn back together in a cosmic game of celestial ping-pong? The outcome depends on a myriad of factors, including the distribution of dark matter and the precise trajectories of the galaxies. One thing is certain: the encounter will be a spectacular display of cosmic fireworks, with stars being flung into new orbits, gas clouds colliding, and potentially a burst of new star formation. The study of galactic drift is not just about predicting the future, but also about understanding the past. By observing the motion of Andromeda and other galaxies, astronomers can reconstruct the history of the universe. The Andromeda Galaxy, for instance, shows signs of having collided with other galaxies in the past. These ancient encounters have shaped its structure and influenced its evolution. The local group, the cluster of galaxies that includes the Milky Way and Andromeda, is a dynamic system where galaxies are constantly interacting. These interactions can lead to the formation of new stars, the disruption of galactic disks, and even the merging of galaxies. The implications of galactic drift extend beyond the realm of astronomy. The motion of galaxies is a testament to the interconnectedness of the universe. Every star, every planet, and every galaxy is part of a vast, cosmic web. The study of galactic drift is a reminder of our place in this web. It is a humbling thought that our galaxy, the Milky Way, is not an isolated entity, but a participant in a grand, cosmic dance. The future collision with Andromeda is a stark reminder of the dynamic and ever-changing nature of the universe. It is a spectacle that we may never witness, but it is a testament to the enduring mystery and beauty of the cosmos. The Andromeda Galaxy, a brief overview. The Andromeda Galaxy, also known as M31, is our closest major galactic neighbor, residing approximately 2.5 million light-years away from the Milky Way. It's a barred spiral galaxy, much like our own, but it's significantly larger, with an estimated trillion stars to our Milky Way's 100-400 billion. Andromeda is also home to a supermassive black hole at its center, which is about 140 million times the mass of our Sun. This galaxy is visible from Earth with the naked eye on dark nights, appearing as a faint, fuzzy patch in the constellation Andromeda. It's been extensively studied, providing astronomers with valuable insights into galactic evolution and structure. In about 4.5 billion years, the Andromeda Galaxy and the Milky Way are expected to collide and merge, an event that will dramatically reshape our cosmic neighborhood. This galactic collision is inevitable, driven by the mutual gravitational attraction between the two galaxies. Despite the dramatic nature of this event, the space between stars is so vast that direct stellar collisions are unlikely. Instead, the galaxies will pass through each other, creating a spectacular display of tidal tails and streams of stars. The exact outcome of this merger is difficult to predict, but it could result in a single, larger elliptical galaxy. This future encounter adds a sense of suspense to our understanding of Andromeda, making it more than just a distant celestial object. It's a harbinger of our galaxy's future. Speculation about Andromeda's future collision with the Milky Way has sparked intense debate and fascination among astronomers and the public alike. Some theories suggest that the merger could trigger a burst of star formation, as gas and dust are compressed and heated. Others propose that the supermassive black holes at the centers of both galaxies could eventually merge, creating an even more massive black hole. The exact timeline and details of these events remain uncertain, but the prospect of witnessing such a monumental cosmic event has inspired numerous studies and simulations. These projections not only deepen our understanding of galactic dynamics, but also remind us of the dynamic and ever-changing nature of the universe. Historical observations. Andromeda through the ages. The night sky has always been a canvas for human curiosity, and among the myriad of celestial bodies, the Andromeda Galaxy has held a special place. Ancient astronomers, gazing up with the naked eye, saw it as a faint, fuzzy smudge. The Persian astronomer Al-Sufi was the first to catalog it in 964 Anno Domini, describing it as a small cloud in his book of fixed stars. He had no idea that this cloud was a distant galaxy, a concept far beyond the understanding of his time. For centuries, Andromeda remained a mysterious object, its true nature shrouded in the darkness of space and the limits of human knowledge. As telescopes improved, So did our understanding of Andromeda. In the 18th century, French astronomer Charles Messier included it as the 31st entry in his famous catalogue of deep sky objects. He thought it was a nebula, a cloud of gas and dust within our own galaxy. It wasn't until the early 20th century that astronomers began to suspect that Andromeda was something more, something far beyond our Milky Way. The debate was settled in 1920 during the Great Debate between Harlow Shapley and Heber Curtis, although it wasn't until Edwin Hubble's observations in the 1920s that the extragalactic nature of Andromeda was confirmed. This revelation opened a new window into the universe, revealing that our galaxy is just one among hundreds of billions. Looking ahead, Andromeda's future is intertwined with our own. In about 4.5 billion years, the Milky Way and Andromeda are expected to collide, merging into a single, larger galaxy. This cosmic dance has already begun, with Andromeda hurtling towards us at around 110 kilometers per second. The collision will be a spectacular event, reshaping the night sky for any hypothetical observers on Earth. Stars will be thrown out of the newly formed galaxy, and the supermassive black holes at the centers of both galaxies will merge, sending out gravitational waves that ripple across the universe. It's a stark reminder of the dynamic and ever-changing nature of the cosmos. Modern astronomy, tools to study Andromeda. In the vast expanse of the cosmos, Andromeda, our nearest major galactic neighbor, has long captivated astronomers. To unravel its mysteries, modern astronomy employs an array of sophisticated tools. Telescopes, both ground-based and space-based, are the primary instruments used to observe Andromeda. The Hubble Space Telescope, for instance, has provided stunningly detailed images of the galaxy, revealing its intricate structure and the vast number of stars it contains. On the ground, telescopes like the Keck Observatory in Hawaii and the Very Large Telescope, VLT, in Chile have also made significant contributions. These telescopes are equipped with advanced spectrographs that can analyze the light from Andromeda, providing insights into its composition, velocity, and distance. Spectroscopy is a crucial technique in studying Andromeda. By breaking down the light from the galaxy into its component wavelengths, astronomers can identify the elements present and their abundances. This helps in understanding the galaxy's star formation history and chemical evolution. Additionally, the Doppler effect, observed in the spectra, allows astronomers to measure the velocity of stars and gas within Andromeda, providing clues about its rotation and the distribution of dark matter. Future projections suggest that even more advanced spectrographs, like those planned for the Extremely Large Telescope, ELT, will revolutionize our understanding of Andromeda's dynamics and evolution. Another powerful tool in the astronomer's arsenal is interferometry, which combines the light from multiple telescopes to achieve unprecedented resolution. The Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, for example, uses this technique to study the cold gas and dust in Andromeda, which are the raw materials for star formation. By mapping the distribution and motion of these materials, astronomers can predict where and when new stars will form. Moreover, future space missions like the James Webb Space Telescope, JWST, will peer through the dusty regions of Andromeda, revealing the hidden processes of star birth and galaxy evolution. The suspense builds as astronomers await the wealth of data these advanced tools will provide, promising to unravel the enigmatic tale of our galactic neighbor. The study of Andromeda is not just about understanding a single galaxy, it's about comprehending the broader universe. Andromeda is on a collision course with the Milky Way, an event projected to occur in about 4.5 billion years. This impending galactic merger makes Andromeda a crucial subject of study, offering a unique opportunity to observe the processes involved in galaxy collisions and mergers. By using these modern astronomical tools, scientists can create detailed models and simulations, blending fact and speculation to predict the outcome of this cosmic dance. The future of Andromeda research is bright, with each new tool and technique bringing us closer to unraveling the mysteries of our universe. The Milky Way, our home galaxy. Nestled within the vast expanse of the cosmos, our home galaxy, the Milky Way, is a sprawling, barred spiral galaxy that has been our celestial address for billions of years. It's a city of stars with an estimated 100-400 billion residents, each with its own story, its own light, and its own journey. Our solar system is but a tiny speck in this grand metropolis, located in the Orion Arm, a minor spiral arm between the Sagittarius and Perseus arms. The Milky Way is a dynamic place, with stars being born, living, and dying in a cycle that has been repeating for eons. It's a place of beauty and mystery, a place that has piqued human curiosity and inspired countless myths, stories, and scientific endeavors. The Milky Way is not a static entity. It's a living, breathing, evolving galaxy. It's on a collision course with its nearest neighbor, the Andromeda Galaxy. This isn't a sudden, unexpected event, but a slow, inevitable dance of gravity and time. The two galaxies are approaching each other at a speed of about 110 kilometers per second. In about 4.5 billion years, they will collide and merge, forming a new, larger galaxy. This event, known as the Milky Way Andromeda collision, will be a spectacular display of cosmic forces. It's a future that's both thrilling and humbling, a reminder of the grand scale of the universe and our place within it. The Milky Way Andromeda collision is not something to be feared, but rather something to be marveled at. It's a natural part of the galaxy's life cycle. In fact, the Milky Way has collided with other galaxies in the past. These collisions have shaped the galaxy we see today, adding stars, gas, and dust, and even triggering bursts of star formation. The future collision with Andromeda will be no different. It will be a slow, drawn-out process, taking billions of years to complete. The stars within the galaxies are so far apart that direct collisions between them will be rare. Instead, the galaxies will pass through each other, their shapes distorted by gravitational forces, before eventually merging into one. The future of the Milky Way is not just about the Andromeda collision. It's also about the evolution of the galaxy itself. The Milky Way is a dynamic place, with stars being born, living, and dying. It's a place where new stars are formed from clouds of gas and dust, where old stars explode in spectacular supernovae, and where black holes lurk at the center, pulling in matter and emitting powerful jets of energy. It's a place of constant change, a place where the past, present, and future are all intertwined. And it's our home, a place that we are only beginning to understand and appreciate. The Milky Way is more than just a galaxy. It's a story, a journey, and a mystery that we are all a part of. Galactic collision course, Andromeda's trajectory. In the vast expanse of the cosmos, our Milky Way galaxy is not alone. A colossal neighbor, the Andromeda Galaxy, is on a trajectory that will eventually bring it into a dramatic encounter with our own. This isn't a distant, abstract concept. It's a cosmic inevitability. Andromeda, also known as M31, is hurtling towards the Milky Way at a speed of about 110 kilometers per second. This might seem alarmingly fast, but in the grand scheme of the universe, it's a slow-motion collision that won't reach its climax for another 4 billion years. The path of Andromeda is a dance of gravitational forces. It's not a straight-line collision, but a complex waltz influenced by the gravitational pull of both galaxies. As they approach, their outer spiral arms will begin to intertwine, a process that will take millions of years. Stars within these galaxies are so far apart that direct collisions are unlikely. However, the gravitational interactions will cause a spectacular display of stellar chaos. Gas and dust will collide, triggering a firestorm of new star formation. The night sky, as seen from any potential planets, will be ablaze with the birth of new suns. Future projections paint a vivid picture of this galactic merger. Computer simulations suggest that the Milky Way and Andromeda will eventually form a single, larger galaxy. This new entity has been dubbed Milkomeda, or Milkdromeda. The exact nature of this merged galaxy is still a subject of speculation. It might retain a disk shape, or it could evolve into a more elliptical form. The supermassive black holes at the centers of both galaxies will also play a crucial role. They will likely merge, creating a single, even more massive black hole at the heart of the new galaxy. The process will be accompanied by intense bursts of radiation visible across the universe. The suspense lies in the unknown details. Will the merger trigger a wave of star formation that will light up the cosmos? Or will it lead to a cataclysmic event that disrupts the delicate balance of both galaxies? The answers to these questions are still shrouded in the mysteries of the universe. One thing is certain. The collision of Andromeda and the Milky Way will be a spectacle of cosmic proportions, a testament to the dynamic and ever-changing nature of the universe. It's a reminder that in the grand tapestry of the cosmos, change is the only constant. The role of gravity in galactic movement. In the vast expanse of the cosmos, gravity is the unseen puppeteer, orchestrating the dance of galaxies with an invisible hand. Our Milky Way and the Andromeda Galaxy are no exception to this cosmic ballet. Gravity, the force that keeps our feet on the ground, also binds galaxies together and governs their movements. It's the reason why Andromeda, our nearest large galactic neighbor, is inexorably drawn towards us. The mutual gravitational attraction between the Milky Way and Andromeda is causing them to move towards each other at a speed of about 110 kilometers per second. This cosmic rendezvous is expected to culminate in a galactic collision, or rather a merger, in about 4.5 billion years. The role of gravity in this galactic movement is not just about attraction. It's also about the distribution of mass within each galaxy. The visible matter, like stars, gas, and dust, contributes to the gravitational pull. However, the majority of the gravitational force comes from dark matter, an invisible and mysterious substance that makes up about 85% of the matter in the universe. This dark matter halo surrounding each galaxy significantly influences their movement and interaction. As Andromeda and the Milky Way approach each other, their dark matter halos will begin to interact and merge, setting the stage for the grand galactic spectacle. The future of this galactic encounter is a subject of intense study and speculation. Current projections suggest that the initial collision will be a slow, drawn-out process, lasting hundreds of millions of years. The galaxies will pass through each other, their shapes distorted by gravitational forces, before retreating and then finally merging completely. The exact outcome is difficult to predict, as it depends on various factors, including the precise distribution of dark matter and the initial conditions of the encounter. Some simulations suggest that the resulting galaxy might resemble an elliptical galaxy, while others predict a more complex structure. One thing is certain, though: the merger will significantly alter the landscape of our galactic neighborhood. The suspense lies in the unknowns. What will happen to the stars, planets, and other celestial bodies within these galaxies? Will our solar system survive the merger, or will it be flung into the intergalactic void? These are questions that astronomers are still grappling with. What is clear is that gravity, the same force that causes an apple to fall from a tree, will be the driving force behind this cosmic event. It's a stark reminder of the interconnectedness of the universe and the profound influence of gravity, even on the largest scales. The Andromeda-Milky Way merger is not just a future event. It's a testament to the enduring power of gravity, shaping the cosmos in ways both seen and unseen. Dark matter, the invisible force. In the vast expanse of the cosmos, the Andromeda Galaxy is on a collision course with our own Milky Way. This titanic encounter, predicted to occur in about 4.5 billion years, is not just a dance of stars and gas. It's a cosmic waltz choreographed by an invisible force, dark matter. This enigmatic substance, which makes up approximately 85% of the matter in the universe, does not emit, absorb, or reflect light, making it invisible to our current telescopes. Its presence is inferred through gravitational effects on visible matter, such as the rotation of galaxies and the bending of light around massive objects. Dark matter's role in the Andromeda-Milky Way collision is pivotal. It's the unseen scaffolding that holds galaxies together and influences their movement. As Andromeda approaches, its dark matter halo will interact with that of the Milky Way, setting the stage for a complex gravitational ballet. The visible parts of the galaxies, the stars, gas, and dust, will follow the lead of the dark matter, their paths dictated by its gravitational pull. The exact outcome of this encounter is uncertain, but simulations suggest that the two galaxies will merge, forming a new, larger galaxy. The dark matter halos will likely merge as well, creating an even more massive gravitational well. The future of this cosmic merger is shrouded in mystery, much like dark matter itself. One intriguing possibility is that the merger could provide astronomers with a unique opportunity to study dark matter in action. As the two galaxies interact, the distribution and behavior of dark matter could become more apparent, offering clues to its nature and composition. Some theories suggest that dark matter particles might annihilate or decay during the merger, producing high-energy radiation that could be detected by future observatories. However, this is purely speculative, and much remains unknown about the properties of dark matter. Another fascinating aspect is the potential impact on the galaxy's supermassive black holes. Each galaxy is believed to harbor a supermassive black hole at its center, and these could eventually merge as well. The dark matter halos would influence the black holes' trajectories, guiding them towards each other. The merger of two supermassive black holes would be an extraordinary event, releasing a tremendous amount of energy in the form of gravitational waves. These ripples in space-time could be detected by advanced observatories, providing further insights into the nature of gravity and the invisible forces at play. The Andromeda Galaxy's approach is not just a spectacle of cosmic proportions. It's a window into the enigmatic world of dark matter, promising to reveal secrets that could reshape our understanding of the universe. Measuring galactic distances, the parallax method. The vastness of space presents a formidable challenge when attempting to measure distances, especially to something as enormous as the Andromeda Galaxy. One of the most reliable methods for measuring distances within our galaxy and to nearby galaxies is the parallax method. This technique relies on the apparent shift in the position of a star against the background of more distant stars as the Earth orbits the Sun. By observing this tiny angular shift, astronomers can apply trigonometry to calculate the distance to the star. The parallax method is most effective for stars within a few thousand light-years of Earth, but it forms the foundation for other, more advanced distance-measuring techniques used for more distant objects. Andromeda, our nearest major galactic neighbor, is a staggering 2.5 million light-years away. Directly measuring its distance using the parallax method is impractical due to the minuscule angular shifts involved. However, astronomers have developed a chain of distance-measuring techniques that build upon the parallax method. For instance, they use Cepheid variable stars, which have a well-established period luminosity relationship, to extend distance measurements to galaxies like Andromeda. By first calibrating the luminosity of Cepheids using the parallax method for nearby stars, astronomers can then measure the distances to more remote objects with greater accuracy. Looking ahead, the future of galactic distance measurements is bright with the advent of advanced technologies. The European Space Agency's Gaia mission, for example, is creating an unprecedentedly precise three-dimensional map of our galaxy by measuring the parallax of nearly 1 billion stars. This data will not only refine our understanding of the Milky Way, but also improve our knowledge of Andromeda's distance and trajectory. As we gather more data, the suspense builds around the eventual collision between the Milky Way and Andromeda, projected to occur in about 4.5 billion years. Understanding the exact distance and movement of Andromeda is crucial for predicting the nature of this cosmic event. Speculation abounds regarding the outcome of this galactic merger. Will the two galaxies collide head-on, or will they pass through each other in a dramatic dance before merging? The precise distance and relative velocity of Andromeda will determine the nature of this encounter. Current measurements suggest a slow, inevitable approach, but the exact details remain uncertain. As our measurement techniques improve, so too will our ability to predict the future of our galactic neighborhood. The parallax method, though limited in scope, remains a vital tool in this ongoing quest for cosmic understanding. Andromeda's size and structure, a spiral beauty. Andromeda, our closest major galactic neighbor, is a mesmerizing spiral galaxy that has captivated astronomers and stargazers alike. Spanning an impressive diameter of about 220 light-years, it is significantly larger than our own Milky Way, which measures roughly 100 light-years across. This vast expanse makes Andromeda a true cosmic giant, its size alone a testament to its grandeur. The galaxy's structure is a classic example of a barred spiral, characterized by a prominent central bulge and sweeping spiral arms that radiate outward. These arms, composed of stars, gas, and dust, are the nurseries where new stars are born. They're luminous blue stars standing out against the backdrop of older, redder stars. The spiral arms of Andromeda are not just aesthetically pleasing. They play a crucial role in the galaxy's dynamics. They act as density waves, compressing interstellar gas and triggering star formation. This process is ongoing, meaning Andromeda is constantly evolving, with new stars being born even as older ones age and die. The central bulge, on the other hand, is home to older, redder stars and is thought to harbor a supermassive black hole at its heart. This black hole, while not directly visible, exerts a profound influence on the galaxy's structure and behavior. Looking to the future, Andromeda's size and structure will play a pivotal role in the fate of our own Milky Way. The two galaxies are on a collision course, destined to merge in about 4.5 billion years. This cosmic dance will be a spectacle of epic proportions, reshaping both galaxies and giving birth to a new, hybrid galaxy. The exact outcome of this merger is difficult to predict, but it is likely that the larger Andromeda will dominate the process. Its size and structure will influence the final form of the merged galaxy, determining the distribution of stars, gas, and dust. The spiral arms may be disrupted or even destroyed, while the central bulges of both galaxies could merge to form a new, larger core. The supermassive black holes at the hearts of both galaxies will also interact, potentially merging to form an even more massive black hole. This future projection adds a sense of suspense and anticipation to our study of Andromeda, making it not just a subject of scientific inquiry, but a cosmic drama unfolding over billions of years. Stellar populations, stars in Andromeda. Andromeda, our closest spiral galaxy neighbor, is a vast cosmic metropolis teeming with stars. Its stellar populations are as diverse as they are numerous, painting a complex picture of its history and future. The galaxy is home to an estimated 1 trillion stars, a staggering number that dwarfs our own Milky Way's population of around 100-400 billion. These stars are not uniformly distributed, but are instead grouped into distinct populations, each with its own characteristics and stories to tell. The bulge of Andromeda, a dense, spherical concentration of stars at its core, is dominated by old, red stars. These ancient suns, some nearly as old as the universe itself, provide a glimpse into the galaxy's early days. They are typically metal-poor, meaning they contain fewer heavy elements than younger stars. This is because the universe was predominantly composed of hydrogen and helium in its infancy, with heavier elements being forged and scattered by subsequent generations of stars. The bulge's stars are also tightly packed, with their strong gravitational interactions causing them to move in complex, chaotic orbits. Beyond the bulge, the galactic disk of Andromeda is a sprawling, pinwheel-shaped region where most of the galaxy's star formation occurs. Here, young, hot, and massive stars burn brightly in blue hues, their intense radiation illuminating the surrounding gas and dust. These stars are metal-rich, reflecting the enriched interstellar medium from which they formed. They are also arranged in a more orderly fashion than their counterparts in the bulge, following near-circular orbits around the galactic center. However, their brilliance is fleeting. These massive stars exhaust their nuclear fuel quickly, culminating in spectacular supernova explosions that seed the galaxy with heavy elements, enriching the next generation of stars. Looking to the future, the stellar populations of Andromeda are set to evolve dramatically. In about 4.5 billion years, the Andromeda and Milky Way galaxies are expected to collide and merge, triggering a burst of star formation. The gravitational interactions will likely disrupt the orderly motion of stars in the disks, sending them on new, chaotic orbits. The merger will also mix the stellar populations, creating a new galaxy with a unique blend of stars. The exact outcome is uncertain, but one thing is clear. The stellar populations of Andromeda will continue to shape its destiny, just as they have for billions of years. The suspense lies in the details, the subtle shifts and dramatic changes that will unfold over cosmic timescales, reshaping our understanding of galaxies and their stars. Nebulae and star formation in Andromeda. Nebulae, those vast interstellar clouds of dust, hydrogen, helium, and other ionized gases, are the nurseries of star formation. In the Andromeda Galaxy, also known as M31, these nebulae are not just scattered randomly. They are concentrated in regions where the raw materials for star formation are abundant. The most famous of these is the Andromeda Galaxy's central bulge, a dense, spherical concentration of stars, gas, and dust. Here, the gravitational forces are intense, and the gas is compressed, triggering the birth of new stars. The spiral arms of Andromeda, with their characteristic dust lanes, are another hotspot for nebulae and star formation. These arms are not static. They are waves of density that move through the galaxy, compressing gas and dust and sparking the formation of new stars. The process of star formation in Andromeda is not a quiet, gentle affair. It is a violent, dynamic process, with massive stars forming and then exploding as supernovae, enriching the interstellar medium with heavy elements. These elements, in turn, become part of the next generation of stars and planets. The most massive stars in Andromeda, known as O and B stars, have short lifespans, living fast and dying young in spectacular supernova explosions. These explosions can trigger the formation of new stars in their vicinity, creating a chain reaction of star formation. The remnants of these supernovae, such as the famous Cassiopeia A in our own Milky Way, can be seen as bright, glowing nebulae in Andromeda. Looking to the future, the Andromeda Galaxy holds many mysteries and surprises. As it approaches the Milky Way, the gravitational interactions between the two galaxies will likely trigger a burst of star formation. The gas and dust in both galaxies will be compressed, leading to the birth of new stars. This process is already underway in Andromeda, with astronomers observing an increase in the rate of star formation in the galaxy's outer regions. The future of Andromeda is uncertain, but one thing is clear: it will be a spectacular show, with nebulae glowing brightly and new stars being born. The exact details of this process are still being studied, but the potential for discovery is immense. The Andromeda Galaxy, with its nebulae and star formation, is a dynamic, ever-changing entity, offering a glimpse into the past, present, and future of our universe. Black holes, the heart of Andromeda. Nestled at the heart of the Andromeda Galaxy, a colossal black hole lurks, its immense gravity shaping the very fabric of the galaxy. This supermassive black hole, known as Andromeda's central black hole, is a titan among its kind, with a mass estimated to be around 100 million times that of our Sun. It resides in the core of the galaxy, a region teeming with stars, gas, and dust, all orbiting around this invisible behemoth. The black hole's presence is inferred from the high velocities of stars and gas near the galactic center, a telltale sign of an object with an enormous gravitational pull. In the future, as Andromeda and our own Milky Way galaxy continue their inevitable dance towards each other, these two supermassive black holes will eventually meet. This cosmic encounter, projected to occur in about 4 billion years, will be a spectacle of epic proportions. The black holes will spiral towards each other, emitting gravitational waves that ripple through the fabric of space-time. These waves, predicted by Einstein's theory of general relativity, will carry away energy, causing the black holes to gradually draw closer. The final merger will be a cataclysmic event, releasing an enormous amount of energy and creating a single, even more massive black hole. Speculation abounds about the nature of this future merger. Some theories suggest that the merger could trigger a burst of star formation, as gas and dust are compressed and heated by the gravitational forces at play. Others posit that the merger could disrupt the orbits of stars and planets, potentially leading to a wave of stellar collisions and ejections. The exact outcome is uncertain, but one thing is clear. The merger of Andromeda's central black hole with our own galaxy's supermassive black hole, Sagittarius A*, will be a transformative event, reshaping the very structure of the merged galaxy. The study of Andromeda's central black hole offers a unique window into the mysteries of the universe. By observing its behavior and interactions, astronomers can test theories of gravity, black hole physics, and galaxy evolution. The black hole's immense mass and proximity, in cosmic terms, make it an ideal target for study. As our understanding of these enigmatic objects grows, so too does our appreciation for the role they play in shaping the cosmos. The heart of Andromeda, with its supermassive black hole, is not just a fascinating object of study. It is a testament to the awe-inspiring complexity and beauty of the universe. Galactic mergers, a common cosmic phenomenon. In the vast expanse of the cosmos, galaxies are not static islands of stars. They are dynamic entities that interact, collide, and merge. This process, known as galactic merging, is a common phenomenon that has shaped the structure and evolution of the universe. Our own Milky Way galaxy is no exception to this cosmic dance. In fact, it is currently on a collision course with the Andromeda Galaxy, its nearest massive neighbor. This impending encounter is a stark reminder of the dynamic and ever-changing nature of the universe. The Andromeda Galaxy, also known as M31, is a spiral galaxy similar in size and structure to the Milky Way. It is located approximately 2.5 million light-years away from us and is approaching at a velocity of about 110 kilometers per second. This means that, in a few billion years, the two galaxies will collide and eventually merge into a single, larger galaxy. This event, often referred to as Milkomeda or Milkdromeda, will have profound implications for both galaxies and their contents. Galactic mergers are not rare occurrences. In fact, they are a fundamental aspect of galaxy evolution. The universe is filled with examples of galaxies in various stages of merging. For instance, the Antennae galaxies, a pair of colliding galaxies in the constellation Corvus, provide a spectacular example of the dramatic changes that can occur during a galactic merger. The gravitational interactions between the two galaxies have triggered intense star formation, creating a dazzling display of young, hot stars and glowing nebulae. The future of the Milky Way and Andromeda is a subject of intense study and speculation. Current projections suggest that the initial encounter between the two galaxies will occur in about 4 billion years. However, the actual merger will take much longer, potentially hundreds of millions of years, as the galaxies gradually coalesce under the influence of gravity. During this process, the supermassive black holes at the centers of both galaxies will also merge, releasing an enormous amount of energy in the form of gravitational waves. The outcome of this cosmic collision is uncertain. The merged galaxy will likely be an elliptical galaxy, a type of galaxy that is more spherical and lacks the distinct spiral arms of the Milky Way and Andromeda. The exact structure and properties of the resulting galaxy will depend on a variety of factors, including the initial conditions of the merger and the detailed physics of the interaction. One thing is certain, though: the merger will be a spectacular event, reshaping the night sky and potentially altering the fate of any life that may exist within the combined galaxy. The future of the Milky Way and Andromeda. In the vast cosmic ballet, the Milky Way and Andromeda galaxies are locked in a gravitational dance, slowly but inevitably drawing closer to each other. Currently, Andromeda, also known as M31, is hurtling towards us at a speed of about 110 kilometers per second. It's the most distant object visible to the naked eye, a faint, fuzzy smudge in the night sky. The two galaxies, each with their own retinue of satellite galaxies, are the dominant members of the local group, a cluster of galaxies that includes our cosmic neighborhood. The Milky Way, with its spiral arms and central bar, and Andromeda, with its massive bulge and intricate dust lanes, are destined for a collision. In about 4.5 billion years, give or take a few hundred million, the Milky Way and Andromeda will begin to merge. This isn't a sudden, explosive event, but a slow, gravitational tango that will take billions of years to complete. The galaxies will pass through each other, their stars and dark matter halos interacting and merging. It's a cosmic dance that will reshape both galaxies, creating a new, larger galaxy often referred to as Milkomeda or Milkdromeda. The exact outcome is difficult to predict, as it depends on complex factors like the exact trajectories and the distribution of dark matter. However, simulations suggest that the merger will likely result in an elliptical galaxy, a type of galaxy that is more three-dimensional and less structured than a spiral. The future of the Milky Way and Andromeda is a tale of cosmic evolution. Stars, for the most part, will remain unscathed. The space between them is so vast that direct collisions are rare. However, the merger will trigger bursts of star formation as gas and dust are compressed and stirred up. The supermassive black holes at the centers of both galaxies will also merge, creating a single, even more massive black hole. This process will send out gravitational waves, ripples in the fabric of space-time that could potentially be detected by future generations of astronomers. The merger will also eject many stars into the intergalactic void, creating a halo of stars around the new galaxy. The fate of our solar system is also a topic of speculation. It's possible that the Sun and its planets will be flung into a wider orbit around the new galaxy. Alternatively, we might be pulled towards the galactic center, where the environment is more extreme. It's also possible that we'll be ejected from the galaxy altogether, becoming intergalactic wanderers. However, these scenarios are highly uncertain. The merger is a slow process, and the Sun will have become a red giant and died long before the merger is complete. The fate of any potential human descendants is even more uncertain, as it depends on factors we can't predict, like technological advancement and the stability of the Earth's environment. Timeline of the collision. When will it happen? In the vast expanse of the cosmos, our Milky Way galaxy is on a collision course with the Andromeda Galaxy. This celestial event, often referred to as the Milkomeda or Milkomeda collision, is not a sudden, explosive event, but a slow, gravitational dance that has been unfolding for millions of years. The journey of these two galaxies towards each other is a testament to the dynamic and ever-changing nature of the universe. The initial approach began hundreds of millions of years ago, but the actual collision is still far in the future. Current projections suggest that the first close encounter will occur in about 4.5 billion years. This is a timescale that is difficult to comprehend, but it is a reminder of the immense scale of cosmic events. As the two galaxies draw closer, their mutual gravitational attraction will cause them to spiral towards each other. This process will take hundreds of millions of years, during which the galaxies will pass through each other, their stars and gas clouds interacting and merging. The exact timeline of this collision is influenced by various factors, including the distribution of dark matter and the gravitational interactions between individual stars and star systems. The first close pass is expected to occur in about 4.5 billion years, but the galaxies will not merge completely until much later, perhaps not for another 2-3 billion years after that. The entire process is a slow, intricate ballet of celestial bodies, a spectacle that will unfold over billions of years. The future of our solar system in this cosmic merger is a subject of much speculation. It is highly unlikely that the Sun and its planets will collide with any stars in the Andromeda Galaxy, due to the vast distances between stars. However, the gravitational perturbations caused by the merger could disrupt the orbits of planets and other celestial bodies. The exact outcome for our solar system is uncertain, but it is clear that the collision will have a profound impact on the structure and dynamics of both galaxies. The merger will likely trigger a burst of star formation, as gas clouds are compressed and collapse under their own gravity. This could lead to the birth of new stars and planetary systems, adding to the rich tapestry of the universe. The collision between the Milky Way and Andromeda galaxies is a reminder of the dynamic and ever-changing nature of the cosmos. It is a process that will unfold over billions of years, shaping the future of both galaxies and their constituent stars and planets. While the exact timeline and outcome of the collision are still uncertain, the study of this cosmic event provides valuable insights into the nature of galaxies and the forces that govern their evolution. It is a testament to the enduring mystery and beauty of the universe, a spectacle that will continue to captivate astronomers and stargazers for generations to come. Simulating the galactic merger. In the vast expanse of the cosmos, the Andromeda Galaxy, also known as M31, is on a collision course with our own Milky Way. This galactic merger, predicted to occur in about 4.5 billion years, has captivated astronomers and astrophysicists who are eager to understand the intricate dance of these two spiral galaxies. Simulating this colossal event is a complex task that involves advanced computational models and a deep understanding of gravitational forces, dark matter, and the behavior of stars and gas within galaxies. Supercomputers are employed to run these simulations, breaking down the merger into millions of individual components. Each star, each gas cloud, and even the enigmatic dark matter halos are treated as separate entities interacting gravitationally. The simulations reveal a dramatic scenario where the two galaxies initially approach each other, their outer spiral arms stretching and twisting under tidal forces. Over hundreds of millions of years, they will merge, forming a single, larger galaxy often referred to as Milkomeda or Milkomeda. The exact outcome, however, is far from certain. The simulations suggest that the merger could result in a variety of outcomes, depending on the initial conditions and the complex interplay of forces. Future projections paint a picture of a transformed cosmic landscape. The merger will likely trigger a burst of star formation as gas clouds collide and compress, leading to the birth of new stars. Simultaneously, the supermassive black holes at the centers of both galaxies will spiral towards each other, eventually merging in a cataclysmic event that will send gravitational waves rippling through the fabric of space-time. These waves, though faint, could potentially be detected by future generations of astronomers, providing a direct window into the dynamics of the merger. The suspense lies in the uncertainty of the final structure of Milkomeda. Will it be a massive elliptical galaxy, or will it retain some of the spiral structure of its progenitors? The answers lie in the ongoing refinement of these simulations, which continue to push the boundaries of our understanding of galactic evolution. The simulations also raise intriguing questions about the fate of our solar system. While the probability of stars directly colliding is low due to the vast distances between them, the merger will undoubtedly disrupt the orbits of stars and planetary systems. Our Sun, now middle-aged, will be well into its senior years by the time of the merger. The increased gravitational perturbations could potentially eject the solar system from the newly formed galaxy or alter its trajectory in unpredictable ways. Speculation abounds, but one thing is clear. The merger of Andromeda and the Milky Way will be a spectacle of cosmic proportions, a grand finale to the current structure of our galactic neighborhood. The simulations serve as our best tool for unraveling the mysteries of this inevitable encounter, offering a glimpse into the future of our universe. Surviving the collision, the fate of stars and planets. In the vast cosmic ballet, the Andromeda Galaxy is on a collision course with our own Milky Way. This titanic encounter, predicted to occur in about 4.5 billion years, will reshape the celestial landscape. Stars, those luminous beacons of the night sky, will find themselves in a gravitational dance like no other. The sheer scale of this event is hard to fathom. Andromeda, with its trillion stars, is hurtling towards us at a speed of about 110 kilometers per second. The distance between us is shrinking, and the inevitable collision will be a spectacle of cosmic proportions. When galaxies collide, the outcome for individual stars and planets is far from straightforward. Stars are so far apart that direct collisions are exceedingly rare. Instead, the gravitational forces will tug and pull, altering the paths of stars and sending them spiraling into new orbits. The Milky Way and Andromeda will merge, forming a new, larger galaxy. This process will take millions of years, and the fate of our solar system is still a subject of debate. Some simulations suggest that the Sun and its planets could be flung into a wider orbit around the galactic center. Others predict that we might be pulled towards the new core, where the density of stars will be much higher. Planets, too, will feel the gravitational tug of war. The Earth's fate is particularly intriguing. If the Sun's orbit is disrupted, Earth could be cast into the outer reaches of the galaxy, where it would be colder and darker. Alternatively, it might be pulled closer to the galactic center, where the environment would be more chaotic and potentially hazardous. The long-term effects on life are speculative, but the collision itself is unlikely to directly destroy planets. The real threat would come from the increased likelihood of close encounters with other stars, which could disrupt planetary orbits and lead to catastrophic events. The collision will also trigger a burst of star formation. The vast clouds of gas and dust in both galaxies will collide and compress, leading to the birth of new stars. This stellar nursery will be a spectacular sight, but it will also mean that some regions of the merged galaxy will be more dangerous. Supernovae, the explosive deaths of massive stars, will become more frequent. These events can release deadly radiation and send shockwaves through space. For any life forms that manage to survive the initial upheaval, the risk of extinction will be significantly higher. Yet, amidst this chaos, there will be opportunities for new worlds to form and new life to emerge. The collision of Andromeda and the Milky Way will be a testament to the dynamic and ever-changing nature of the universe. The birth of a new galaxy, Milkomeda. In the vast cosmic ballet, our Milky Way galaxy is on an inevitable collision course with its nearest neighbor, the Andromeda Galaxy. This dance, set in motion by the inexorable pull of gravity, will culminate in a spectacular merger, giving birth to a new galaxy, Milkomeda. The encounter, predicted to begin in about 4.5 billion years, is not a sudden, cataclysmic event, but a slow, graceful waltz that will unfold over billions of years. As the two galaxies approach, their outer edges will begin to intertwine, a process that will eventually result in a single, elliptical galaxy. The exact nature of Milkomeda is a subject of intense speculation and study. Current projections suggest that the merger will trigger a burst of star formation, as vast clouds of gas and dust are compressed and ignite into new suns. The supermassive black holes at the hearts of both galaxies will also converge, spiraling towards each other in a cosmic dance that will culminate in a final, dramatic merger. This event is expected to send out a massive burst of gravitational waves, ripples in the fabric of space-time that could, in theory, be detected by future generations of astronomers. The fate of our solar system in this new galaxy is uncertain. The vast distances between stars mean that direct collisions are unlikely, but the gravitational perturbations could disrupt the orbits of planets and even eject some from their home systems. It's also possible that the Sun will be flung into a new region of the galaxy, with a completely different night sky. The merger will also have profound implications for life on Earth, assuming it still exists. The increased star formation could lead to a higher rate of supernovae, which might bathe the planet in deadly radiation. On the other hand, the merger could also provide a new source of heavy elements, the building blocks of life. The birth of Milkomeda is a reminder of the dynamic, ever-changing nature of the universe. It's a process that will take billions of years, a timescale that is almost incomprehensible to our human minds. Yet, it's a process that we can study and understand, using the tools of modern astronomy. The merger of the Milky Way and Andromeda is not an end, but a beginning. It's the birth of a new galaxy, a new chapter in the story of the universe. And who knows what life, if any, will call Milkomeda home. Impact on the solar system. Will Earth survive? In the vast expanse of the cosmos, the Andromeda Galaxy, our closest spiral neighbor, is on a collision course with the Milky Way. This celestial dance, set to begin in about 4.5 billion years, raises intriguing questions about the fate of our solar system and, more specifically, Earth. The journey of Andromeda towards us is a slow, inevitable process, currently hurtling through space at approximately 110 kilometers per second. This might seem fast, but it's a leisurely stroll on cosmic scales, meaning we have eons to ponder our planet's destiny. As the two galaxies merge, the gravitational forces at play will be immense, reshaping the very fabric of both the Milky Way and Andromeda. Stars, including our Sun, will be thrown into new orbits, and the solar system could be jostled like a pebble in a cosmic river. The exact path of our Sun and its planets through this galactic maelstrom is uncertain. It's possible that the Sun will be flung into a new orbit, far from the galactic center, or it could be drawn closer to the supermassive black hole at the heart of the merged galaxy. In either scenario, the change in our star's environment could have profound implications for Earth. The survival of Earth hinges on several factors, the most critical being the stability of the Sun. If the Sun's orbit is disrupted, it could lead to changes in its lifespan and behavior. An increase in solar activity, for instance, could strip away Earth's atmosphere or bombard the planet with harmful radiation. Conversely, if the Sun is ejected from the merged galaxy, it might enter intergalactic space, where the absence of heavy elements could hinder the formation of new planets and stars. However, it's essential to note that these are speculative scenarios. The timescales involved are so vast that the Sun will have long since entered its red giant phase, engulfing Earth, before the galactic merger even begins. Moreover, the merger itself might not be the cataclysmic event popular culture often portrays. Galaxies are mostly empty space, and the distance between stars is so vast that direct collisions are unlikely. Even if the solar system is thrown into a new orbit, the chances of a close encounter with another star are slim. That said, the increased gravitational perturbations could lead to a more chaotic environment, potentially ejecting some planets from the solar system or altering their orbits. For Earth, this could mean a change in climate, a shift in the position of the planets, or even a new night sky filled with the stars of the merged galaxy. The future, it seems, is as uncertain as it is fascinating. Life in a merged galaxy, speculative scenarios. In the vast cosmic ballet, the Andromeda Galaxy is on a collision course with our own Milky Way. This galactic merger, predicted to occur in about 4.5 billion years, will dramatically reshape our celestial neighborhood. The gravitational dance between the two galaxies will likely result in a single, larger elliptical galaxy, tentatively dubbed Milkomeda or Milkdromeda. The implications for life within this merged galaxy are as vast as they are speculative. Stars, including our Sun, will be tossed around like dice in a cosmic crapshoot. The vast distances between stars mean that direct collisions are unlikely, but the orbits of planets could be disrupted. Our solar system might be flung into a new region of the galaxy, potentially altering the very fabric of life on Earth. Temperatures could shift dramatically, affecting everything from climate patterns to the very chemistry of life. Yet, life is resilient. It has thrived in the harshest environments on Earth, from the depths of the ocean to the scorching heat of deserts. Who's to say it couldn't adapt to a new cosmic home? The night sky, a familiar tapestry of constellations, will be unrecognizable. The merged galaxy will boast a new array of stars, nebulae, and perhaps even new planets. For any life forms observing the heavens, the familiar patterns of the Milky Way will be replaced by an entirely new celestial landscape. This could spark a renaissance in astronomy and navigation, as civilizations adapt to their new cosmic surroundings. The merger might also trigger a burst of star formation, leading to a plethora of new solar systems. Some of these could harbor conditions suitable for life, offering new opportunities for evolution and exploration. Speculation about the merger's impact on intelligent life is even more intriguing. Civilizations in the merged galaxy might develop unique cultures and technologies shaped by their shared cosmic history. They might view the merger as a unifying event, fostering cooperation and collaboration on an unprecedented scale. Alternatively, competition for resources could lead to conflict. The merger could also accelerate technological advancement, as societies strive to understand and harness the energies of their changing galaxy. In the end, the story of life in a merged galaxy is one of adaptation, resilience, and the enduring spirit of exploration. Cultural impact. How the collision influences human thought. The vast, spiraling dance of galaxies has long captivated human imagination, but none more so than the impending collision of our Milky Way with the Andromeda Galaxy. This cosmic event, predicted to occur in about 4.5 billion years, has begun to weave its way into the fabric of human thought, influencing art, philosophy, and even our collective psyche. The sheer scale of this celestial encounter, a slow-motion collision that will reshape our galactic neighborhood, has sparked a wave of introspection and creativity. Artists and writers have started to grapple with the enormity of this event, using it as a metaphor for change, impermanence, and the interconnectedness of all things. For instance, science fiction novels and films have depicted the collision as a backdrop for stories of human resilience and adaptation, exploring themes of survival and transformation in the face of cosmic upheaval. Philosophers and scientists alike are drawn to the existential questions posed by the Andromeda collision. The idea that our galaxy will merge with another challenges our sense of permanence and isolation in the universe. This cosmic event forces us to confront the transient nature of our existence and the vast, unpredictable forces at play in the cosmos. Some see it as a reminder of our insignificance in the grand scheme of things, while others view it as an opportunity to reflect on our place in the universe and the potential for new beginnings. The collision has also inspired a sense of wonder and curiosity, driving advancements in astrophysics and cosmology as researchers strive to understand the mechanics of galactic mergers and their implications for the future of our solar system. Looking ahead, the cultural impact of the Andromeda collision is likely to grow as our understanding of the event deepens. Future projections suggest that the merger will create a new, larger galaxy, potentially altering the night sky as we know it. This transformation could inspire a new wave of artistic and philosophical exploration as humans grapple with the changing cosmos and their place within it. The collision may also influence our approach to space exploration and colonization, as the prospect of a merged galaxy sparks interest in the potential habitability of new worlds. In this way, the Andromeda collision serves as a powerful catalyst for human thought, shaping our collective imagination and driving us to explore the mysteries of the universe. Observing Andromeda. Tips for amateur astronomers. Nestled in the constellation of the same name, the Andromeda Galaxy is a mesmerizing sight for amateur astronomers. It's the closest major galaxy to our own Milky Way, lying a mere 2.5 million light-years away. This makes it a prime target for stargazers equipped with modest telescopes or even a pair of binoculars. To spot Andromeda, you'll want to find a dark sky location far from the glow of city lights. The galaxy appears as a faint, elongated smudge, best observed in the autumn and early winter months in the northern hemisphere. Patience is key, as it can take a while for your eyes to adjust and pick out its subtle glow. In the coming decades, Andromeda will become an even more spectacular sight. Our galaxy and Andromeda are on a collision course, currently hurtling towards each other at around 110 kilometers per second. In about 4.5 billion years, they will merge, creating a new, larger galaxy. While this might sound like a cataclysmic event, the stars within each galaxy are so far apart that individual stars are unlikely to collide. Instead, we can expect a dazzling display of celestial fireworks as the galaxies interact, their shapes distorting and new stars forming in the gravitational dance. For amateur astronomers, this means that Andromeda will appear larger and brighter over time, offering an ever-changing view. To get the best view of Andromeda, consider using a telescope with an aperture of at least 8 inches. This will allow you to resolve some of the galaxy's structure, such as its bright core and the dark dust lanes that crisscross its spiral arms. A nebula filter can also enhance the contrast, making it easier to pick out these subtle features. For astrophotographers, long-exposure images can reveal even more detail, from the galaxy's vast halo of stars to the faint, wispy structures that extend far beyond its bright core. As technology advances, amateur astronomers will have access to increasingly sophisticated tools, opening up new possibilities for exploring Andromeda and other distant galaxies. One of the most exciting aspects of observing Andromeda is the sense of connection it fosters. When you gaze upon this distant galaxy, you're seeing light that has traveled for millions of years to reach your eyes. You're also looking at a glimpse of our own galaxy's future, a reminder of the dynamic and ever-changing nature of the universe. As you track Andromeda's slow approach, you're bearing witness to one of the most dramatic events in cosmic history. So, grab your telescope, find a dark sky location, and prepare to be awestruck by the beauty and mystery of our nearest galactic neighbor. As we've journeyed through the cosmos, we've uncovered the fascinating tale of Andromeda, our celestial neighbor that's on a collision course with the Milky Way. We've seen how, in about 4.5 billion years, the Andromeda Galaxy will begin to merge with our own, creating a spectacular galactic spectacle. This isn't just a distant possibility, it's a cosmic inevitability, a dance of galaxies written in the stars. Imagine, for a moment, standing on the surface of a future Earth, looking up at the night sky. The once familiar constellations have shifted, merged, and transformed. The Andromeda Galaxy, once a faint smudge of light, now dominates the heavens, its stars intertwining with our own in a celestial ballet. This is the future that awaits us, a future where the boundaries between galaxies blur and merge. But this is just the beginning. The universe is vast and full of mysteries waiting to be uncovered. In our next exploration, we'll delve into the enigmatic world of black holes, those cosmic giants that warp space and time. We'll explore their origins, their behaviors, and the role they play in the grand tapestry of the cosmos. So, join us as we continue our journey through the wonders of the universe. The adventure is far from over, and the best is yet to come. Stay curious, stay explorative, and until next time, keep looking up.